Forget everything you thought you knew about contemporary engineering. In a corner of northern Japan where the ocean shows no mercy and geology conspires against any human attempt, the country pulled off what countless experts bluntly called a lethal folly. A project that shouldn't work. A challenge that, on paper, bordered on madness. 54 kilometers in length, buried beneath the depths of the ocean floor, connecting two islands that the sea had promised to keep separated forever. Honshu and Hokkaido. Two landmasses condemned for millennia to depend on weather, currents, and patience. But Japan decided not to accept that fate. This isn't just an underground passage, it's not merely infrastructure. Today, it stands as irrefutable proof of how far human control can reach when confronting a rebellious, violent, and relentless nature. Or today, we are diving into the depths of a technological feat that the planet still struggles to accept as real. A work that doesn't seek to impress, but inevitably does. The most abysmal descent of your existence begins now. 1. The Seikan Tunnel. Close your eyes for a moment. Imagine the crushing weight of the Pacific Ocean exerting constant pressure from above. Millions of tons of water pushing relentlessly day and night, year after year. In that hostile void separating the islands of Honshu and Hokkaido, humanity erected an underground barricade that defies all apparent logic. The Seikan Tunnel. At 240 meters below the sea surface, we're not simply talking about a railway corridor. We're looking at one of the greatest demonstrations of structural tenacity ever executed by humankind. For decades, the Tsugaru Strait was considered impassable. Violent currents, constant seismic activity, and treacherous geology turned it into a death trap for any engineer bold enough to attempt it. And yet, they tried. The engineering challenge was colossal. Construction teams had to drill through 9 active seismic faults, zones where the earth never sleeps and rock moves with a life of its own. Add to this a volcanic composition so unstable it threatened to collapse the tunnel with every meter gained. Each advance was a negotiation with disaster. The true ingenuity lay in a chemical grouting injection system at extreme pressures, capable of sealing invisible fissures before water could find its way. To this was added a reinforced concrete lining almost a meter thick, designed not only to withstand ocean pressure, but also the constant tremors of the Japanese subsoil, an armor that admits no compromises. But even that wasn't enough. The tunnel incorporates a massive pumping system ready to evacuate up to 2,500 tons of salt water per minute. Not just in case, but because leaks are permanent. The ocean never stops trying to reclaim what it considers its own. Keeping the interior dry isn't an occasional condition, it's a continuous battle. If anyone tried to replicate this work today, the initial budget wouldn't drop below 7.5 billion euros, a figure that triples the cost of Europe's most advanced rail networks. And even with that money, the technical challenge would remain extreme. To put it in perspective, for a Madrid resident, it would be like building an underground route directly from Puerta del Sol to the heart of Segovia. Crossing mountain ranges submerged under tons of water in absolute silence, interrupted only by Earth's pulse. In the end, Seikan isn't just concrete, steel, and technology. It's the legacy of a nation that refused to accept the separation imposed by the ocean. A silent but forceful declaration. Geography doesn't dictate destiny when human ingenuity decides to intervene. The Seikan Tunnel doesn't just connect two islands. It connects past and future. It connects necessity and audacity. It connects the heritage of extreme engineering with the promise of ultra-fast transport. And beneath the ocean, in perpetual darkness, it remains there, resisting, defying, reminding us how far humans can go when they decide not to give up. 2. The Three Gorges Dam. There are constructions quantified in linear dimensions and others, like the Three Gorges Dam in China, that are evaluated by their influence on Earth's very rotation. By retaining such a colossal volume of water in its 600-kilometer reservoir, this behemoth has redistributed so much mass that, according to NASA, it has modified the world's inertia. With a capacity of 22,500 megawatts, its 32 colossal turbines are true metal basilicas of 400 tons each, designed to transmute the fury of the Yangtze River into immaculate electrical energy. The construction feat was an unparalleled operation. The erection of giant cofferdams and diversion channels that dried the bed of one of the world's most torrential rivers to inject 27 million cubic meters of concrete. For an observer in Spain, the total cost of this undertaking, calculated at 32.5 billion euros, is like building more than 15 stadiums like Santiago Bernabeu or fully funding the national high-speed rail for 10 years. This dam transcends being a power plant that feeds a tenth of Chinese citizens. It's an essential bulwark that moderates floods that once claimed thousands of lives. It symbolizes the perfect balance between limitless human daring and the urgency to safeguard society. A milestone in the era where we tame natural titans. 3. Cable-stayed bridges. Imagine a form that appears to levitate in the mist, held only by silk filaments gleaming in the sun. In truth, these cable-stayed bridges are some of the most refined support machines ever conceived. Unlike classic suspension bridges, here each cable attaches directly to the central pylons, generating a network of pressures and tensions that makes it possible to span enormous distances with unparalleled visual grace. The technological mystery lies in the core of those cables, not a monolithic block, but bundles of hundreds of interwoven galvanized steel wires, wrapped in high-resistance polyethylene to combat marine oxidation for over a century. Each stay cable is stretched with millimetric precision via computer-guided hydraulic jacks, allowing the bridge deck to flex subtly in strong winds without suffering fatigue. In Spain, the Constitution of 1812 bridge in Cadiz leads this methodology with an expense exceeding 510 million euros and a height that eclipses the Tower of Hercules. These links aren't just functional connections. They are emblems of architectural innovation, illustrating how mathematical equations convert masses of metal into ethereal artistic pieces that merge communities and shape the profiles of our modern coastlines. 4. The automatic track-laying machine. In the past, assembling railway networks was a savage labor task that devoured thousands of souls and years of effort. Now that work is delegated to a being of pixels and metal, the automatic track-laying machine. This autonomous constructor convoy is a rolling plant that spreads ballast, positions sleepers, and fuses rails with sub-millimetric precision in a fluid, orchestrated rhythm. The ingenuity lies in its high-resolution laser guidance, which maps the terrain in real time and corrects alignment so that bullet trains travel at 350 km per hour without vibrations. This innovation not only quintuples construction speed but eradicates human errors at joints where a loose bolt could precipitate disaster. One of these mobile beasts involves an outlay of 25 million euros, but its productivity cuts hundreds of millions in future repairs. Watching this colossus operate under a storm or in the darkness of a tunnel, we witness total robotization, a tomorrow where global infrastructures build themselves with a meticulousness no army of workers could match. 5. River diversion channels. To build in the heart of an untamed river, you must first banish water from its ancestral domain. Flow redirection is one of the most intense and decisive stages of civil engineering, a strategic duel against hydrodynamics. Through cofferdams, temporary barriers of stone and soil, and the creation of titanic diversion roads, specialists force the river to flow through a fictional path, leaving the original bed dry and suitable for heavy equipment. The trick lies in controlling erosion. The alternate channel must have precise slope and texture so the flow doesn't accelerate and destroy the ephemeral walls. Ultrasonic flow detectors are deployed in this phase, alerting to variations upstream, allowing site evacuation if a flood threatens. In world-scale projects, this preparation can absorb up to 200 million euros of the total. It's a tribute to the audacity of engineers who descend into the void of an evaporated river, laboring in a race against the clock before nature demands its original course back. A reminder that all progress begins with reverence for primal forces. 6. Then smart road construction. A modern highway goes beyond a mere layer of dark bitumen. It's a stratified network designed to resist time and climatic rigors. The procedure starts with soil cement, a stabilized base that distributes loads from massive trailers toward the depths of earth. The secret of its extreme robustness is in the surface layer, a compound of bituminous asphalt and flexible polymers applied at 170 degrees Celsius. This formula is self-healing. Facing minor cracks, it drains rainwater via regulated porosity, preventing lethal hydroplaning. In Spain, a kilometer of cutting-edge motorway costs 8 to 14 million euros, an expense that ensures optimal flow of goods and travelers. Future roads already integrate fiber optics and inductive charging for electric cars beneath their skin. When traveling these highways, we rarely reflect on the effort of intelligent compactors and pavers that smooth each section with orbital precision. These arteries are the veins sustaining the economic heartbeat, ensuring development reaches the most remote corners. 7. Vertiblock. When there's an urgent need to stop the advance of thousands of tons of soil on a slope, the classic answer is a bland, unattractive concrete wall. However, the vertiblock method has revolutionized the landscape by mixing structural resistance with the beauty of masonry. These precast modules are unique for their hollowness that allows filling them with gravel to optimize drainage and enhance their internal gravitational mass. The ingenuity lies in their tongue and groove coupling that enables walls up to 4 meters without extra steel reinforcements, saving hours and funds. But in populated areas of Costa del Sol or the Pyrenees, this approach is highly demanded, with installation rates between 25,000 and 60,000 euros per section. Beyond its unbreakable firmness, the exterior finish replicates native stone, blending with the environment instead of assaulting it. Vertiblock illustrates that territorial containment needn't be a visual affront, but an advance that infuses protection and scenic charm to our urban habitats, elevating a technical requirement to environmental art. 8. Facade panel assembly. In the 21st century, raising an office tower is no longer brick upon brick, but panel upon panel. The assembly of prefabricated envelope panels is a dance of exactness, where titanic cranes hoist integral segments of glass and alloy up to 6 meters. The mystery lies in factory-grade thermoacoustic insulation. Each unit arrives at the site with its barriers and drainage ducts pre-installed, ensuring immediate air tightness. With lasers and positioning automata, technicians anchor one panel every quarter hour, completing a skyscraper's skin in record time. In cities like Barcelona or Madrid, where construction deadlines impact real estate value, this 300,000 euro tool is vital to minimize investors' financial costs. This practice not only saves fortunes in personnel, but promises aerospace-grade finishing, evidencing that modern construction has evolved from craftsmanship to cutting-edge industrial assembly, clean and productive. 9. Geocell system. Our metropolises suffer a silent ailment. Surplus sealed surfaces causing flooding and elevating urban heat. The geocell system is the indispensable remedy. It's based on a high-density recycled polypropylene mesh forming open cells on the ground. The technical trick is its endurance. Though it looks like ethereal plastic, once filled with pebbles or soil, it resists garbage trucks and emergency vehicles of 100 tons without yielding. This configuration filters rain directly to aquifers, eliminating flooding and relieving treatment plants. In Spain, where cold drop downpours sow annual chaos, its installation runs 45 to 80 euros per square meter, an outlay amortized by avoiding water damage and mitigating heat islands. Geocell embodies future ecological urbanism, a floor that breathes and allows harmony between flora and vehicular traffic in an ideal green union. 10. Eversground Foundation. Every structure is worth what its substrate is. And Eversground has redefined home foundations using waste that others discard. Recycled glass. This method employs foamed glass sheets derived from grinding and expanding glass until generating sealed bubbles, waterproof and thermally efficient. The ingenuity fuses the lightness of an insulator with the solidity of a foundation, eradicating cold bridges that leak winter warmth. Currently in northern Spain, with perennial humidity and frost, implementing Eversground implies about 30,000 euros, promising a perpetually dry and cozy home. It's invulnerable to pests, flames and centennial degradation, the opposite of conventional petroleum polystyrene. Opting for this not only forges a firm pedestal for the family, but closes the recycling loop, yet transmuting waste into the most precious and eternal element of our contemporary architecture. 11. Submarine gas pipelines transporting the fuels that drive the world through abyssal darkness is one of the most arduous and costly enterprises of modern engineering. A silent struggle against pressure, corrosion and distance. These pipelines are X80 steel tubes, alloys designed to withstand extreme tensions, enormous internal pressures, and simultaneously the crushing weight of water columns exceeding 2 kilometers in depth, where any failure would be catastrophic. The art of their laying rests in the pipelayer vessel, an authentic floating nautical city, equipped with colossal cranes and automated systems, where sections are robotically welded in a continuous, precise and relentless sequence after joining. But the pipe is coated with the high-density concrete, not only to anchor it to the seabed, but to protect it from treacherous currents and geological shifts. Then it descends slowly via the Stinger, a curved guide over 100 meters that controls the millimetric descent toward absolute darkness. Undertakings like the Algerian-Spanish pipeline mark milestones exceeding 1.25 billion euros, with each welded joint subjected to industrial radiography and ultrasonic testing, guaranteeing a half-century operational life without concessions to error. These conduits are the hidden arteries that neutralize winter, that keep cities lit and economies moving, linking countries through invisible abysses and demonstrating that human engineering can weave vital bonds even in the most hostile environments of the blue globe. And that's it. Human engineering challenging the inconceivable. But now, tell me your take. Would you dare to cross the Seikan at 240 meters beneath the waves? Or do you prefer to stay on solid ground? Leave it in the comments. I'll be reading them. If this journey through the impossible captivated you, give it a like and subscribe so you don't miss our next technical odysseys. Finally, to showcase these feats from unreachable perspectives, we've combined documentary recreations with AI-generated illustrations, capturing every technical nuance with a clarity impossible until a few years ago. Thanks for joining us, and until the next monumental discovery.